All right, ladies and gentlemen, today we're going to be talking about the layers inside of the Earth. So our first unit was on the exosphere. That was all of outer space. Our second unit was on the atmosphere. That was all the gases on Earth. Today, we're going to be introducing the geosphere, which is all the rocks on Earth. So we're going to take a look at the different ways at which we look at the inside of the Earth. And then we're going to take a look at a web quest that's going to take a deeper dive into the layers and how they were discovered and things like that. So we're going to take an inside scoop of the Earth. All right, first we need to understand the first way in which we can look at the Earth's layers are the compositional layers. Compositional layers are based off of what it's made of, based off of its composition. What elements makes up the different kinds of layers. If we look at the Earth based on the compositional layers, there are three compositional layers. The outermost layer is the crust. Okay, that's the one that we live on. You're currently touching the crust. Technically, we're in the building, but the building itself is touching the crust. So that is the least dense material out of all of them. And there's actually a little bit of variation in how thick that crust is. There's actually two types of crust, and they differ in size and density. So the crust is split up into two types. And if you look at this picture down at the bottom, we have the continental crust. The continental crust, that's the thicker but less dense type of crust. And then beneath the oceans, we have oceanic crust, which is thinner but more dense. The density isn't super important right now, but it is going to play a big role in how these two interact when we see movement happen later on. So they both have a similar composition. They're both made of oxygen, silicon, aluminum, iron, calcium, and magnesium. The main difference is the oceanic crust is a little bit denser because it has twice as much of the heavier metals like iron, calcium, and magnesium. So again, outermost layer is the crust. This is the compositional layers, what it's made of. This is the least dense layer. Then we hit the middle layer. The middle layer is called the mantle. The mantle is all the space in between the crust and the core. So this definitely contains the vast majority of Earth's mass. It's more dense than the crust. That's why it's beneath the crust. And it's less dense than the core. That's why it's outside of the core. And here's the really crazy thing. Nobody, not in our deepest digging sites, deepest caves, deepest drilling in the ocean, no one has ever been able to reach the mantle. And there's a number of reasons for this, but the important thing I want you to take away from that is that everything we know about the inside of the Earth has been made by observations made on the surface of the Earth. And there's actually a really cool way in which we can know what's beneath our feet without actually having to go there. I'm not going to spoil that yet because that'll be towards the end of the lesson, but I want you to keep that in mind. If no one's ever been there, how the heck do we know what is down there? How do I know that there's different layers? So we'll get into that a little bit later. But again, the outermost one was the crust. That was the least dense. Beneath that was the core. And then we finally hit the third compositional layer. Sorry, I think I just said core because someone was walking by and I got distracted. The second layer is the mantle. Apologies. My one mistake for the year. Please don't count. Yeah, it happens on here too. And then the final layer is the core. Okay, the core is the most dense compositional layer of the Earth, and it has little to no oxygen, silicon, aluminum, or magnesium. Basically, all the lighter stuff floated up to the top of the Earth when it was still forming. Got to remember, a lot of this was sorted when the Earth was still a hot ball of magma. And it hadn't solidified yet. So only the heaviest metals like iron and nickel sank to the core. So it's about a third of the Earth's mass, but it is just full of those two metals, nickel and iron. Very little of anything else in the core. And the core is the most dense compositional layer, almost perfectly pure iron and nickel. So those were the compositional layers, the crust, the mantle, the core. And as we saw, as we went further and further down, it got more and more metallic. It got more and more dense. So down at the bottom of your paper, you guys have a little diagram. It looks like a semicircle compared to this one, but we're going to label the three things and label the densities. So that outermost layer, label that the crust. And then down here, you're going to write least dense or lowest density. The middle circle will be the mantle. And the innermost circle will be the core. And please label that the most dense. If you also want to add in a little extra information, you could put an arrow going from the outside in. And as you go down, you could write temperature increases. So the closer to the core you get, the hotter the rock layers get. So the crust is also the coolest compared to the core, which is where there's still a lot of heat on the inside of the Earth. So again, crust, that's the least dense or lowest density. Then that middle one will be the mantle, that's medium density. And then we have the core, and this is the most dense, the highest density. And then, like I said, if you want to draw an arrow going down, you could say that that equals temperature increasing, because the deeper in the Earth you are, the higher the temperature is. All right, now let's start over. And instead of looking at the layers based off of what they're made of, the compositional layers, let's start over on the surface, and let's instead look at the physical properties of the layers. These are called the Earth's physical layers based on how they act. Basically, are they a solid? Are they a semi-solid plastic? Or are they a liquid layer? We're going to see that kind of change as we go down. Again, same Earth, same planet we're talking about. We're just looking at the layers in a different way based off of a different criteria. If we do that, the outermost layer is called the lithosphere. The lithosphere is between 15 and 300 kilometers thick. So it has two parts. It's all of the crust, because remember the crust was between 5 and 15. So that's all of the crust and the upper part of the mantle. And the key here, I want you to put a big circle or put a big star by this is actually the solid piece, and it's broken up into large chunks. The Earth's surface is not one solid sheet of rock. It's broken up into these large chunks called tectonic plates. Again, circle, underline, put a star by that, because we're going to talk a lot about tectonic plates, the crust and the upper mantle being broken up into large chunks, large sections, tectonic plates. So the lithosphere is a solid layer, acts as a solid. If you go down beneath the lithosphere, you're going to hit a layer called the asthenosphere. The asthenosphere is about 250 kilometers thick, and this is a plastic layer of the Earth's interior. Now, what do I mean when I say that word plastic? I'm not talking like toys or rubber or things like that. When I say plastic, it refers to a semi-solid, semi-liquid. It's very hard to explain, but the closest thing I can relate it to is if anyone has ever made or played with that stuff called oobleck, that kind of cornstarchy material that with cornstarch and water and stuff. Basically, if you haven't, here's the rundown. When you squeeze it, it acts like a solid in your hand. It takes up space, it keeps its shape and things like that. But the second you just release your hand and just hold it in your hand, it's actually going to drip through your fingers like a liquid. So this is what we can see with the asthenosphere, the plastic layer. It's very malleable. It means it's bendable. It's not quite solid. It's not quite liquid. Think of it as a very slow flowing solid, maybe like hard clay. You can shape it, you can bend it, you can squeeze it. It's not going to break. It's not brittle or things like that. So again, plastic layer, asthenosphere, semi-liquid, semi-solid. And this is actually the reason that you can't get down into the mantle, because the only reason that this is not a liquid, it is warm enough, it should be a liquid, but the only reason it's not a liquid is because of all the weight of the rock above it pushing down on it. So that makes it act a lot more like a solid. So as soon as you remove that weight by digging it away, well, then it liquefies, it'll erupt, it'll fill that hole like a little volcanic eruption, and then it'll solidify back into solid rock. So this is why we can't get past the asthenosphere to get into the mantle. Next, we have a name that we've heard before. Yes, mesosphere. Yes, there was a mesosphere in the atmosphere that we talked about. That was the middle layer of the atmosphere. And guess what? There's a mesosphere inside the Earth too. And again, it just means middle layer. So this is about 2,550 kilometers thick. Basically, this is the strong lower part of the mantle. It acts more like a solid. Again, it should be hot enough that it's a liquid, but all the weight of the rock above it makes it act like a solid. And it's everything between the asthenosphere and the core. So it goes all the way down to the core. Not much else to say about the mesosphere, so let's go ahead and take a look at the next layer, which is the core. The core is actually broken into two parts. We have the outer core, which is about 2,200 kilometers thick, but here's the key, put a star by this. This is a liquid layer, and I'll explain how we know it's a liquid layer as we go further in the lesson, but it's actually an ocean of flowing liquid metal, because remember, the core is all nickel and iron. Now, this ocean of flowing liquid metal swirls around the inner core, which is a soft solid. It does say solid there, but we could add that word soft solid because we recently found out it's not as solidified, not as strong as we had originally thought. And what we can also see is this liquid metal flowing around the solid inner core. The solid part of the metal actually creates the Earth's magnetic field. This is super important because this blocks a lot of the a lot of the nasty radiation that's coming from the sun. So a lot of that gets bounced off, never reaches the Earth, and it's actually protecting us like a shield. Okay, this is also partly what creates the ionosphere up in the atmosphere, if you remember talking about that, and helps with the northern lights. So the Earth's magnetic field is very important for us on Earth. We can't live on the surface without it, and it's only created because there's a liquid flowing ocean of liquid metal flowing around the inner core. Now, also, it's not in the notes because I just read about it recently, excuse me, but we also believe, due to recent studies, that there might be an inner core, which is actually very strong solid. So we have the inner core, which we believe is a soft solid, easily breakable, stuff like that. But then they believe there might be an inner core. So in the next 10 years or so, I might have to rewrite this lesson because more research has shown that there might be another part inside the inner core that's even more solid. So we'll learn more about that as science learns more about that. So here we can see, looking at the picture, we have the 5 physical layers on the right side. We have the 3 compositional layers on the left side. So you can kind of see how they compare to each other. Remember, compositional, we only had 3, crust, mantle, core. But on the physical side, we had the lithosphere, the asthenosphere, mesosphere, outer core, inner core. And also, this is a lithosphere is a solid, asthenosphere was plastic, mesosphere is back to a solid, outer core was liquid, and then inner core was that soft solid again. So again, it has to do with how they're acting, what kind of state of matter they're in. Now, like I said, we have never been past the mantle, or we've never been past the crust, even into the mantle. So how the heck do we know what's down there? Well, you've probably already done this without realizing it. As you can see, it's up on the screen. It does say earthquakes, but let's talk about that for a moment. Let's say it's around Christmas time or the holiday season. I don't want to pigeonhole anybody to a certain religion, but let's say it's around the holiday season and you have a present under a tree or sitting out in the house somewhere. And let's say you wanted to figure out what was in that present without opening it. Because if you open it, then you're getting in trouble for opening it too early and you don't want that. So what are you going to do? Well, you're going to shake it, right? And if you shake it and you hear 1,000 little pieces, congratulations, you got yourself a Lego set. If you shake it and it's real quiet and real light, guess what? Grandma got you a sweater. Congratulations. If it's real heavy and quiet, maybe you got a book or something. But you can learn about what's inside that present by shaking it and hearing all the different little vibrations and stuff like that. If you take that and apply it to the earth, that's how we know what is inside the earth. It all has to do with earthquakes, the shaking of the ground. Earthquakes release seismic waves, which travel like ripples through a pond. They're going to start in one location and they're going to spread out throughout the inside of the earth. Now, what we need to understand is that these seismic waves move in very predictable ways, and they're read by these devices called seismographs. If you've ever seen a Hollywood movie with an earthquake, you've seen a seismograph. It's that big roll of paper with a pen, and then when the earthquake comes, the pen starts jumping up and down real big, making these big old scratches all over the paper, showing that the earthquake has gotten really strong. Well, seismographs are all positioned all over the globe. And when an earthquake happens, it doesn't just happen in that place. The earthquake's waves actually travel through the inside of the earth. So using some fancy math and figuring out how long it takes the earthquake wave to get to each of the seismographs, we can tell what kinds of materials it went through, because some of these waves can move very quickly through solids. Some move a little bit slower if they're moving through a semi-solid layer, and some can't even move through liquid layers, so they completely disappear. And this is how we know the outer core is liquid, because some of the waves, when they travel through the inside of the earth, they just disappear. They won't show up on the other side of the earth. And earthquakes isn't just a one-time thing. There's actually many earthquakes happening all the time. There's earthquakes happening every single day. They're not always the strongest earthquakes, so we might not notice them. And they not always are happening in our area. We're actually not in an area that sees frequent earthquakes. We'll talk about that later in the week. But we definitely have earthquakes happening in the United States and all over the world. And each time those earthquakes happen, we get a better idea of what's inside the earth by using these, fancy math and computer models to learn about what they must have moved through in order to get to these different places at different times. So shaking of the earth helps us know what's on the interior. So again, two types of layering systems, compositional and physical. Compositional was what it was made of. Physical is how they act. All right, what you guys are going to do now is you're going to head to a web quest. Let me pull that up. That was on the screen, but it is not. Oops. Okay. Space. Layers. Okay, so if you guys turn the page, you're going to see the little practice for today, which is a web quest. It looks like this, okay? Earth structure using data from earthquakes. So you guys are going to head to this website, and I'll go ahead and pull that up on the screen. And what you guys are going to do is it's a little article kind of website with some interactive little animations and stuff like that. It's got some little checkpoints. If you click on the pictures, I think they move, or they did at one point, but they'll show you what's going on with that. And then there's some pictures that you need to answer. This is a very important one. To answer this question, please look at the figure, what it says right here. This will tell you what the answer to this question is. There's one specifically, like when you see this, what would it mean? Keep reading there. But the questions are in order, so you're going to go through, you're going to answer them. It's going to show what the Earth really looks like, how we learned about it, and stuff like that. Like I said, all the questions are in order, so you guys are going to work through the web quest. You can use your phones or the computers in the back. If you use the computers in the back, the Chromebooks, please make sure they get plugged back in. I'm not there to be a pain about it, but please, I don't want to come back to a messy cart. Please make sure those get plugged in. And then once you guys are done, you're going to turn in the web quest, and then you're going to get the exit ticket. And once you've done the exit ticket and turn that in, that means you are good to go for the day, as long as the teacher dismisses you. Okay? So again, go ahead, hop on the web quest, head to this website, make sure you type in everything. It's obviously here, it's working. It's not an easy way for me to give you the link, but go ahead and type that into your Google bar, this right here, with all the capitals and everything and the dashes. Make sure you get all the capitals and dashes, and then that will get you to the right website. You guys are going to answer those questions. Don't worry about taking the quiz. Just go ahead and answer the questions. I don't even think that'll be on there. I think I'm going to delete it before I copy this again, so don't worry about that. So answer the questions. Once you get the questions done, then you turn it in, get the X ticket, complete that, and then you're good to go. Thanks, guys. Thanks for stopping by, and I hope you learned a little bit about the layers of the Earth.